So anyway, Lakers suck, Yankees suck, Barcelona sucks. Who else we got? Cowboys do not. All right, deal. So here we go. Welcome back, algebrists. Yesterday, we did one single example, and just as a quick refresher, we are now sketching this awful function. Okay, now awful maybe isn't fair. We factor as normal, and we just used what type of factorization here? So regular doesn't quite cover it. I mean, maybe, but just to check, I think this is to move from here to here. What did I use? I used a GCF. And what about from this trinomial to these? Grouping or shortcut, whichever way you want to word it. Okay, we then found the zeros and we put them on a number line. Now, remember, we checked each interval. And notice, and I want you to double check yours, when we drew our number line to check what is f of x doing, we never put any other number or any other dash anywhere on this line other than my roots. I want you to never put anything extra on here. Like, notice I pointed to this, right, and said, hey, we used x equals 1, but I would not actually put a dash because it's going to confuse you about where your roots were. Okay, from there, we had simply just the information. We knew that based on the end behavior, that it ended up and down. We knew these were the roots, and we checked whether it was above, positive, or below the axis in between our roots. Okay, this problem, yesterday we finished at the very, very, very end of class. Let's get one more right meow. So, for this one, I'm going to hook you guys up, and it's going to be a little bit nicer. Maybe, I think so. I'm going to call this one g of x. And as we're looking at g of x, I'm going to give it to us in a nice form. So let's say we have the following. We have x plus 2 squared, and x minus 1, and x plus 8. Now, couple things that we have to be concerned with. And I don't have my step 1, 2, and 3 up there anymore, but I think we can still reference it. Yeah, I imagine you guys can see it on your page. Normally, we start by factoring. But what has that already done? It's in its most factored form, right? So we're just starting a step ahead from where we did yesterday. And it's nice when we're in this form. I know that it wouldn't necessarily be nice to type into your calculator or to graph it by hand if you're actually doing the values. But I promise that this is super nice. Because when we get an ugly thing that we're trying to sketch, we factor it to find the what? The zeros or the x-intercepts, the solutions, the roots. If it's already factored, can we find those roots like really quickly? Okay. You say ye. Okay. Cool. So, help me out here. Each of these factors, if we're looking for the roots, what you're not seeing me do is just replace g of x with what? Louder. 0. Okay. What value of x makes this factor equal to 0? I agree, Naomi. How about everybody else? What value of x makes this 0? Negative 2. Now, here's the weird part. The fact that it's squared, I didn't do this, and I never would, and you guys don't necessarily need to write this, but do you agree that this is what it says? X plus 2 times x plus 2 times x minus 1 times x plus 8. Okay. The reason that I'm stressing that, and we won't normally write it, but we're going to see a new word today that that's going to apply to. When I write my roots, do you agree that negative 2 shows up in both of them? So if I had x plus 2 and x plus 2, I would get x equals negative 2 and x equals negative 2. And we've seen this before where the number showed up twice and we only wrote it once. Do me a favor for now, write it twice. The fact that it shows up twice here, and I can tell that it shows up twice because that factor is squared, I want you to physically write it both times. Okay. No, it's not an ordered pair. We're just listing out all the x-intercepts. So this one led to these. Okay, and I'm going to switch colors just so we can keep it straight. What value of x makes this factor 0? 1, I agree. And what factor of x makes the last one 0? Negative 8. Before we continue on, all we've done is given something in factored form. We didn't have to do all that extra stuff to get this. We just identified the roots. Okay, a slightly harder question. We didn't reference this yesterday. We certainly used it. I want you guys talking with your groups for about 30 seconds. It should go quick. I want you to tell me, and I'm going to keep it green for now, what is the end behavior? And you can just write EB. That's how we simply did it. But I'm going to give you a moment, like 30 seconds for real. What is the end behavior? Arrows. We're math dancing. Talk it out. I'm going to call on somebody random. So if you have no idea, make sure you're talking. If your neighbor has no idea, talk to somebody else or ask me. I'm going to give you guys a minute. I'm going to call on somebody. A positive leading coefficient implies to us that our end behavior does exactly this. Okay. That's kind of a tricky question, but I hope that you agree that it's so much easier than if I'd given you the original one in standard form and then made you factor. Like, that's easier to get. Okay, with all this information, I have the roots. I know what my end behavior looks like. The end behavior we didn't formally do yesterday, but it's a good review to have. Where do I put all these zeros? Put them on a number line. Deal. All right. I'm going to keep with green here. And let's see. Here's my number line, and I'm paying no thought to the scale. What is the name of the function that we're working with right now? G, right? It's g of x. So I'm just going to make sure that that's clearly labeled. Here is my function that we're plugging in. And what numbers go on my number line? So -2, and I don't know why I'm switching to a different color. -2, and I'm not going to write it twice because here it is. Boom, twice. What else? Ooh, I'm going to have to change this here in a second, I can tell. What's the furthest left? That's what I should have done first. If I'm putting these in a number line, -8 is going to be first. Okay, and then we get a -2. And what's the last number? Why -1? 1. Yep. Okay, I'm okay with 1. Now, the same question we asked yesterday, I didn't get a whole lot of, nobody asked questions about it, but we were toward the end of the hour. When I put those 3 numbers on my number line, how many pieces or intervals did we just cut it into? 4 of them. We have 1, 2, 3, and 4. Okay, what do I do now? Okay, so give me something specific that I can check. Like, what do you want me to do? Like, how do I check if it's positive or negative? Because I agree with you. So when you say it, I still not quite following. What's it? Okay, so remember the thing about, let's think about if it's a relevant answer. Because I think you're on the right track. But what do you mean it? So the roots are always 0. They're never going to be positive or negative, right? Because these are the zeros. But check it out. What did we do yesterday? If I scroll up just a hair here, I did not use -3. I picked, how do we decide -4? So we're going to clarify real quick. If you're zoning out or distracted, I'm going to say just stop for a second. I need something in this furthest left interval. Something between -infinity and -8. And I don't care what it is. -9, -10, -50, they all work. I'm going to plug in -9. That's a number that I'm thinking here. And again, notice I didn't check anywhere. I didn't put a tick here. Okay, now all I need to know is g of -9 going to be positive or negative. And there's something awesome that happens with this function. No matter what I plug in here into this x for this first factor, it gets squared. Which means no matter what, it's always going to be what? Positive. So I know that since I only care about the sign, I'm just going to check that first factor, no matter what I plug in, is going to be positive. And I can show, like, we'll check -9 plus 2 is -7. Squared is a positive 49. It's always positive. If I plug in a -9 into my second factor, -9 minus 1, positive or negative? Negative. And how about my last one? -9 plus 8. Negative. Now, I don't care about the number, right? All I care about is the sign. If I have a positive and I multiply it by a negative and then by a negative, what does my answer come up? Are you sure? Positive. Positive times negative is a negative times a negative here gets me back to positive. I now know that G is positive here. So we have to, because I'm plugging it into each of my factored forms instead of like the big ugly one. Like yesterday when we did this problem, I could have plugged it into this. But it's so much easier to see positive or negative just by plugging in here. Because these are all equivalent. Kennedy. Yep, so I'm going to be more specific. We're going to plug in these values, and I'm going to, like, this is going to be all of them here, for x in original. And I don't care about the number. We could get the numbers if we wanted, but I'm literally, there's 3 factors, or 4, depending on how you word it, written up here. I'm going to plug an x in anywhere there's an x. Okay, so I know it's positive here, which does that agree with our up and up? The very furthest left, it should be positive. Yeah. Yeah, if it goes up forever, it better be positive. Okay, pick something in here. -3 is a good choice, and I'm switching colors just arbitrarily here. If I try -3, let's plug it in. This first one, no matter what, is always going to be what? We already decided always positive. What if we plug in a -3 into this one? -3 minus 1 is negative. What if we plug in a -3 into this one? It's a positive. So if I do positive times negative times positive, what is it going to give me? Negative. Sebastian. It's definitely going to be one of them, but we have to decide which, right? Because if we want to sketch our graph, there's a huge difference if it goes above the x-axis or not. Okay. What's positive times a negative going to give me? Times a positive. And there it is. Yep, a positive times a negative is a negative. Times a negative makes it positive again. Now, you're going to be tempted. Right now, if you haven't done it yet, what's the sign going to be here? What do you, anybody got feeling? Positive is a natural thought, right? Don't assume. Let's check. Pick something in here. 0. So let's try it. Here's 0. We're going to pick something in this interval. Okay, if I plug in a 0 for each of these, and I'm going to add this one, Kennedy, just so we can see it. 0 plus 2. And you guys, if you don't need this, it's okay to just do it like we have been. But these are the thoughts that we're doing, and I'm just plugging it in. Here is where I'm plugging them in, because that's my function. So 0 plus 2 squared, gives me a what? Positive. 0 minus 1? And 0 plus 8. Okay, so you guys said a second ago positive, but let's check. What's positive times negative? Negative times a positive? Huh. Take that assumption. Okay, based on this, the fact that this is what our end behavior said, what should it do on this last interval? Should we really truly just trust that, or should we check it? We should check it. Now, there is a shortcut living in here somewhere. We just might not see it yet. We're going to check what value here. Something bigger than 1. 2. So when we plug that in, let's see, we get a positive for this first one. Back into every single one of these, when we plug in these numbers, Kennedy, it's going to go in here. Either my factored form is what I will typically plug into, or if you really wanted to, it's more work, but like on yesterday's, we didn't start with factored. We could have plugged it in here and gotten positive or negative all the same. Every time it's going to plug back into original, and I'm going to say original g of x in this case. Just add one word there. Okay, but back to checking at 2. That's a positive. What's 2 minus 1 going to give me? Positive. What about 2 plus 8? And if you do a positive times a positive times a positive, your answer is positive. Okay. For these, again, I want to stress, we're just sketching. We are not making perfect graphs. This is much nicer than if I had said make a table with 50 values. This is easier. It's nicer. Okay. I'm going to go ahead and graph this. And we, rather, are going to graph this. So as I'm looking, the only thing that I am thinking about is I need to see these x values, -8, -2, 1 on my scale. So if you want to draw it square, you can, but I'm going to make sure that mine shows everything. So I know here's -5 on my scale, here's -10, and it keeps going forever. I'm not even going to put a y scale on because we're just sketching. Okay. Again, just so you know why my scale is wonky, it's because I need to be able to see -8 on the x-axis, I need to be able to see -2, and I need to be able to see +1. Okay. While we put these pieces together, I'm going to start, And I'm going to do the end behavior last just so that it matches and looks nicer. But I'll use orange to actually graph it. I'm going to plot my roots first. My x-intercepts. There's one at -8. We already found that. There's one at -2. And there's one at +1. Okay. We have all three roots knocked out. Now, end behavior I will hit at the very, very end. Between -8 and -2, this range was my function positive or negative. Which, what does that mean in my graph? Below the x-axis. So everywhere in this range, I'm below the x-axis. Now, I know it has to get back up there. I don't know if it does it like this, and I don't know if it does it like this, but are they both negative on that whole interval? So if we're just sketching, I'm just going to go with the nicer one. It's this. What about my next one, between -2 and 1? It's negative. So this is the first time that I think we've seen this happen. I'm going to let this curve back down because it had to stay negative, right? It went up to 0, and I'm going to just fix that one a little. It went up to 0, and then it stayed negative for another minute. What does it do on the end? End behavior, what do we say it does? Or I can look at it here and say, hey, anywhere between -8 and -infinity, it's positive, and it's the same statement. This goes what direction forever? Up, boom. And this one goes what direction forever? So careful, what do we say it is between 1 and infinity? Positive. Or I could ask that question differently and say, what's my end behavior? It's up to the right. There it is. Okay, we have secured the dub, apparently. No? Okay. I thought it was good. Okay, how close do you think we are? Just out of curiosity. I honestly have no idea. I can't graph this one in my head. Apparently my class isn't found. We're going to ask Desmos what the deal is. So we're going to graph this function and just see, is our sketch kind of close? And my gut says kind of. I don't know. We only have 8 minutes if you're going to pop yes. Okay, x + 2 squared and x - 1. And what's up? Okay. Okay, so here's their function. Does ours look similar? You don't think so? So, again, but check it out. I agree that you say not even close. I think I disagree with you. Does this have a W shape? Now, we didn't know if it went down to -5 or if it went down to -50 or -200. Could we figure it out if we wanted? Yeah, we could get a couple points and actually say, not only is it positive or negative, but what's the actual value, and we could get a better graph. But if all we need is a sketch, we still have the same general shape. It's still a W. You say I'm wrong or that we're not close, but I'm not even convinced that's not true. What's my Y scale? Yeah, so like theirs goes down. I don't know how far it goes down, but we can check. Theirs goes all the way down to negative, goodness gracious. I'm going to zoom out. They go down to -230, about. Why do you think mine doesn't? No, like, I'm not, just in general, like, I agree it looks different, but why can't this just be -230? Couldn't I pick that scale? Like, I could change my Y jump and, like, make it look wider or thinner, depending on how much it jumped by. This could be -230. I didn't pick the scale. I never said what Y value we're at, other than it's below. This could be the same graph. And I'll play around with it. I'll show you tomorrow that I can change the settings just on how we view it to see that it will be the same. Okay, these things. Thumbs up, thumbs down. Where are we feeling with it? Okay. Graphing, it's kind of weird. I agree. Okay. I'm going to give you guys an assignment right meow. I got you. And let's see. I probably have it already written. Ooh, man. Love it. Okay. Your assignment tonight. I think I'm going to start making this kind of a habit, to be honest. I'm going to give you an assignment now. Today's Wednesday, right? Guarantee I collect it Friday, because I'm going to add problems to it tomorrow. Cool. So, I got you. Yes. Okay, so that said logged out, whatever. Okay, for tonight, it's going to be super chill. Not a ton. I just want you to see if you have issues with it. We're going to call this homework 3.5.1. And I'm just going to call it homework 3.5, realistically, because I'm just going to add to it. It's the same assignment. Homework 3.5 you will find on page 156. It might actually be 155, but I trust that you can turn it back a page if that's needed. All right. Cool. And actually, super easy. I want you to do 12 through 16. Odds and evens. Correct. Okay. Now, a couple things I want you to be aware of. Okay. While you're looking at it, first off, so here's the first couple, just so you're aware, and I'll keep these up. But if you're struggling with this and you don't want to check your notes for whatever reason, your book tells you where we should check. Yeah. See example 1 if you, See example 1 if you want help with these problems. On the second ones, I don't know what the deal is, but I'm just going to close it. Your book tells you where to look if you need extra help with it. Use that to your advantage. Cool. You guys have a couple minutes. Realistically, you could probably get the first couple done in the next 3 minutes. Cool, cool.